Okay, so to continue on from the previous lesson, go ahead and click on this object, and now we're going to switch this to axis angle. Go over here and just open up a new window type and switch this to the graph editor. Well, of course, we don't have any data for the axis angle, so if we scrub with our left mouse button on the timeline, the object is not going to rotate. It will only rotate if you either switch this to Quaternion or Euler, because that's the type of data we have inside the graph editor. So go ahead and click this over here and go to frame 1 and press the I key and capture the rotation. Go ahead and go to frame 50 and press the R key, press the Y key, press the control key down, and rotate again by 90. Make sure to look on the header to see how much you're rotating by. Press the I key and capture the rotation. Now go ahead and put this on frame 100. I'm going to do shift middle mouse button to pan a bit. Press the R key, press the Z key, press the control key down, and rotate this by 90. Press the I key and capture the rotation. And lastly, go ahead, go to frame 150. Press the R key, press the X key, press the control key down, and rotate again by 90. Now press the I key and go ahead and capture the rotation. Now here you can see that we've captured all the rotations on the axis angle. Press the shift and middle mouse button. Let's go ahead and now close this window. So here we can just click over here and move our mouse up, and it will collapse it. Now here what we're going to do is click on this last sphere, go to the Object tab and click on Calculate and do OK. Now do the middle mouse button to position it like this. Go ahead and zoom in. Now what we're going to do is go into File, Save As, and let's just save it as Rotation Concepts 3.blend. Okay, so what I want you to do is go ahead and open this up, not too much, and just switch this to Dope Sheet. Now, the Dope Sheet's purpose is to show you all the keyframes that have been captured by all the objects inside your 3D view. And all those objects are going to be listed over here. Go ahead and click on this object. Since this is the only object that we captured the keyframes from, this is what it's showing. Notice that when you click over here, when you have the object selected, you can go into the action editor. So this is digging in to that specific animation. So objects can have multiple animations that you can link to. Right now it's just cube action. Now here, when we switch to Dope Sheet, we're again simply seeing all the keyframes for all the objects inside the 3D view that have animations. So we're going to stay over here. Now go ahead and open this up. When you move your mouse over here, you can do the scroll wheel to go up and down. When you move your mouse over here, you can do the scroll wheel to compress and expand the view of the frames. You can of course click over here to scroll up and down. Now when you have these little diamond shapes highlighted in yellow, that means all the keyframes are selected. You can press the period key to home in on all the keyframes in the view. Now when everything is selected, you can go ahead and move this scrub to, let's say, over here, and press the S key to scale. You can change the location of the keyframes in this way. Right click to cancel. If you press the G key, you can move all the keyframes position on the timeline. Right click to cancel. Okay, now what I want you to notice over here is that when we have this object selected, I want you to switch over to XYZ Euler. When we go ahead and go back to frame 1, here we had originally rotated around the y-axis. So if you look at this Y, Euler rotation, you can see that there is no orange bar. That means a change has happened between this keyframe and this keyframe on the Y Euler rotation. Because there are no rotations happened on X and Z, you're going to see an orange bar. That's all this means. Whenever you see an orange bar between a keyframe and a keyframe, that means no change happened on that data, the numbers that were coming in. That's all this means. Okay, so you're going to see this on all these different type of rotations. Anyways, what I want you to do is now go over here in the end frame and type in 150 and enter and click on play. Now when we have this object selected, we can of course switch this to quaternion or axis angle. So go ahead and switch to XYZ Euler. Press the 7 key. Now when you are dealing with Euler rotations, you can see that if we are going to rotate our object on all 3 axes, the object, when it comes to rotations in animation, is going to misbehave. This is because Euler rotations are best used when you are expecting to rotate that object when you're creating an animation around a single axis or 2 axes. But if you involve the 3rd axis, then the object is going to run into what is called gimbal lock. We're going to talk about how this concept works a little later. Just do the middle mouse button. I'm going to show you how you can see what's going on. So what I want you to do is go ahead and switch this 3D manipulator to gimbal. If you hover your mouse, you can see that this is all about Euler rotations. This gimbal really is not going to show you any information that would be useful if you switch this to quaternion or axis angle. This is really meant to be used for XYZ Euler. Now go over here and switch this to the rotation. So here you can see that when we are dealing with Euler rotations, we're going to be dealing with a ring-based system. So the reason the object is misbehaving, if we click on pause over here, you can see that originally when the object rotates, it's taking the X ring with it. You can go under File, User Preference, go to Interface. Just remember this number 75. Just go ahead and make this a little bigger. You can see that when the when we rotate this Y around the Y axis, it took the X ring with it. This means we lost a rotational axis. So now when we rotate it on the Z, and then when we try to rotate this object up, there is no axis to rotate around to bring this object back up to the way it is. So here what Blender's doing is quickly trying to align this ring-based system so the object aligns correctly. So this is why the object misbehaves in this way when you're using Euler rotations. We're going to look at this in a bit more detail a little later. I just want you to first get an idea of why this is happening. Okay? Now over here, again, this is not really going to do anything when we have this on gimbal, but go ahead and just switch to quaternion. When we are dealing with quaternions, you can see that the object behaves very nicely. Okay? Now, when we are dealing with quaternions, these values over here are not going to make sense right now. So the way quaternions work is it's actually based on a spike that is driven through the origin point of your object, and your object's interpolation between these rotations is done through this spike. This is what this information is talking about. You're not going to see this visually, and Blender does not have anything over here that will expose this. We're going to learn how to expose this spike. When you are dealing with axis angle, it's going to be the same concept. We're going to be exposing the spike that is used to interpolate between these different rotations between keyframe to keyframe. Anyways, go under File, User Preference, and over here just type in 75 and enter. Now go ahead and switch this off over here back to the way it was so it doesn't come in our way. Now what I want you to do is go ahead and switch this object to Euler and press the 7 key to go to Utopia. Go ahead and click on Play. Now here, if we examine the outer ring, which is exposing the XYZ Euler rotation, we can clearly see that it's not giving us the right rotations when we're dealing with animation. When we look at this inner ring over here that represents quaternions, we can see that it's slightly misbehaving when the object comes over here and tries to rotate back up. When we go ahead and switch this to quaternion, we can see how the object is going to behave. See, it only misbehaves slightly. Now when we switch this to axis angle, which is the last ring over here, you can see that the object misbehaves over here in this area, but it seems to work fine. Okay, so what I want you to do is go ahead and do the middle mouse button and go ahead and just zoom into this area. You can see that when an object approaches a keyframe location, it eases in. You can see that it's slowing down. See how it slows down over here? And then when it starts its rotation, you can see that it kind of pauses, so it's easing out. This is what is called SLIRP, spherical linear interpolation. So by default, this is how all objects are going to behave no matter what type of rotation that you are using. Now we can change this by simply hovering our mouse over here and pressing the T key. So by default, this is SLIRP. Blender just calls it Bezier. Now the other type of rotation that we can use is called LIRP, which is linear interpolation. Go ahead and click this. Now you will see that the object is going to behave a bit more robot-like. Okay, now because we've changed the interpolation to be linear, we of course have to update these motion paths. So go ahead and click on pause. Now first go ahead and switch this to XYZ Euler on this object. I'm going to click on this sphere, go to the object tab and click on update. You'll see that it's going to change. You will notice that we are no longer getting the ease in and ease out if you examine this ring. Go ahead and click on this object and now switch this to quaternion. Go ahead and click on this second sphere and now do update. Go ahead and click on this object and now change this to axis angle. Go ahead and click on this sphere and click on update. Now go ahead and click on play. Now go ahead and click on this object and switch again to XYZ Euler. So you can see that when we are using a linear interpolation, we get a much more cleaner movement, but again, when we're using the XYZ Euler, it still misbehaves when it loses its ring of rotation. Now, when we switch this to quaternion, you can see that this is the animation that we really wanted. So quaternions are really going to always give you the best animations when it comes to rotating around all three axes, right? We're talking about sophisticated animations. Now press the 7 key. You will see that now when we switch this to axis angle behaves very similar to quaternions, but again, they have a bit of difficult time in some situations. You can see this by the motion path. Okay, so you can see that Y bones are always set to quaternion because they give you the best motion paths when you are dealing with rotation. Okay, so now that you have seen this, what I want you to do is go ahead and hover your mouse and press the T key. And here, just for fun, you can see that Blender internally gives you different type of interpolations. Just click on bounce. Now you will see that between keyframe to keyframe, you can change the behavior of this object. Okay, so just press the T key. Now you can spend some time and experiment with this. I'm just going to switch this back to linear. Let's go ahead and click on pause over here. And what we're going to do now is go ahead and switch this to the graph editor. Now this is going to bring up a pretty important topic when you're dealing with rotations. And it has to do with what type of data are you planning to work with when you are going to be rotating your object and creating animations. So if you think about it, because the XYZ Euler rotation is a lot simpler to understand, this would be a good candidate of the rotation mode type to use on the knee joint, the elbow joint, and the finger joints, right? Because it would be pointless to do quaternions, because those type of joints are really just going to be rotating around a single axis or two axes when it comes to the fingers. But it doesn't really matter if you set let's say the knee joint to quaternion. You can still lock it to that single axis, but this simply means that you're going to be working with a much more complex data type. So as you can see that we can of course change these rotation modes at any time after we've created the animation, right? But if we do that, we are not able to latch on to the original rotations. So you saw that when we created the rotation using the Euler angles, when we switched to quaternions, we couldn't latch on to the Euler. This means that we have to create the rotation again. So this means that when you are creating your rigging systems, it is only through experience that you will learn which is the best rotation type to use. Now, when we are dealing with bones, you're going to see that we're going to leave all the deformed bones to quaternion. And when we're working with non-deformed bones, this is where we will get to select which type of rotation mode that we want to use, because it is going to be the non-deformed bones that you will be working with in the graph editor. Now here you can press the period key just like before to see what the graph editor is showing, right? Again, over here you can see that when it comes to the graph editor, it's the same thing. How much a rotation is happening on the Y Euler rotation, and these are your frame numbers. You can zoom in and out, and of course you have to click on this keyframe. So what I want you to do is go ahead under File, do Save As, and save this as Rotation Concepts 4.blend. So I'll see you in the next lesson.